to you.
Thank you very much for inviting me. Thank you for this nice introduction. I have nothing to say more than Peter Molinar has already said. So I can summarize it in two take-home messages. One is study processes, and the second one is don't aggregate individual data. So that's what I'm talking about. Why do we need analysis of processes? Because learning is not constant over time. This is the forgetting curve. It's well known. You have the percentage of recalled information, and you see it changes over time. So if you would measure the recalled information at that point in time or at that point in time, you would get different results. That's the time series of one individual, depressed mode. The message is the same. Mood varies across time. That's mood for one individual for 100 days. And you see it depends on the point in time. If you measure there, you get different results if you measure there. That's a physiological time series, diastolic blood pressure, the same. A lot of variation over time. You can measure, if you measure it at one point in time, you get different results. That's a learning curve from one student measured for one semester. It's the daily learning time. Above you see the learning time for present study. It's the amount of time a student is present in seminars and so on. And here you see the time he spent for self-studies. And what you see here is you have the Christmas break, no self-studying and no seminars. And if you look, you could see a slightly time trend in self-study because of preparation for a lot of examinations. Again, if you study time use of this student, it depends on the point of time where you measure. If you measure here or you measure there, you will get different results. That's the same for a group, for a sample of students, more than 100 students, the same the same time, and you see for present time, study time, you see the regularity as a rhythm. And you see during weekends there are no seminars, the Christmas period, and during holidays there are only block seminars, whereas the self-study time is increasing in the last part. There's another time series, that are older data, but they are quite interesting. That's TV behavior of adolescents in Germany is a representative sample. And what we measured is the daily time where they turn off the TV. So it's an apparatus. Each family has an apparatus which automatically records if you start looking TV, if you change channel, and if you finish. And also it will be data about the person which is looking. So that are at the beginning of the time period 14-year-old teenagers. And what you see, the period is 3 years. You see this measurements, that's the end of the year. They are allowed to view for later point in time at the last day of the year. And what you also can see is the rhythm, the weekly rhythm. At weekends, the adolescents are allowed to view longer than during weeks. You see the yearly rhythm, you see the weekly rhythm. You could see a slight linear trend because they are getting older and they are allowed to view later if they are older. That's a time series, and that's a time series for aggregate data. It makes sense to look at this time at a sample, but normally you should look at individual data. Here you have publication data. It's the amount of publications, articles concerning achievement, motivation. It's also a time series. And these are diary data regarding learning. With diaries, students were asked regarding their motivation. We asked for intrinsic motivation and extrinsic motivation. At the end of this 14 days time period, there was an examination. And what you see is that the that the motivation is changing. The extrinsic motivation is increasing the nearer the examination is, and the intrinsic motivation is slightly decreasing. The same for learning strategies, the same sample. What you see is 2 learning strategies repeating and keynotes, and you see the learning strategies, the use of the learning strategies is changing. That does mean that if you measure learning strategies at this point in time or at this point in time, you will get different results because the exam preparation is a process. The same sample, and also we use diaries. You see here the effective study time. Here is the examination, and you see just before the examination they invest more time. That's one of our models we use, the model of self-regulated learning. I don't want to go into the details, but just one important thing is that a process model because we have different phases. That's the pre-action phase before learning. The action phase is during learning, and the post-action phase is after learning, and we measure it using diaries for each day. And what important is that we assume time lag relationships between these phases, and especially important is that we assume that the learning at the end of one day has an effect on the beginning of learning on the next day. Therefore, it's a cycle of learning, and it's a regulation model. Here we have time series for 2 variables, motivation and goal attainment. It's one individual, and we see the intra-individual correlation between these variables is positive. Here we have, again, diary data for a class of students, 8th graders. And again, you see the amount of time they need for learning each day. And at this point in time, there again is an examination. And you see that one day before the examination, they learn quite a lot. that gives you information about the kind of learning, and we have a lot of data of similar kind, which shows that learning very often is just before examination, and you can imagine that if you learn in this way, you will forget what you learned very quickly. But what is important, again, it's a process, and the learning time is changing, and if you would ask at one point in time, cross-sectionally, how much time you invest for learning, you have to aggregate for yourself with respect to the time period, and it's difficult to aggregate such data correctly. We further differentiated another study von Haag and Michaud. They looked for the time use in the preparation for an examination, and you see the time use, this blue line, it's the same as we had before. They just invest much time direct before the examination. But we also have a green line, which is which doesn't vary very much. And the difference is that are the good students and that are the bad students. The bad students have a different type of learning process, whereas the good students have not that much variability. So that's an interesting information we get from these processes, the amount of variability, and in this kind, the variability for the bad students is more negative. The argument is, one argument is you should look at processes, the other argument you should, you don't aggregate. And often if we want to publish this individual data, the reviewers say, what about validity and internal consistency of this data? And the good thing is you could compute it for each individual. So we have the time course of one individual for 3 items, and you could compute a Cronbach's alpha for this individual. And that's interesting because you can do it for each individual, and if you are interested in internal consistency, you could select only these individuals which have a high internal consistency. Also, you could, here, this is an individual with low internal consistency, but the message is if you do diary studies, you could look at individual internal consistency, and you shouldn't compute consistency measure for the whole sample. That's validity. You measure 2 times a day, for example, mood in the afternoon and mood in the evening. You could measure the stability within this half-day period. And again, you see this stability is different. For this individual, it's quite high, and for another individual, is quite low. What Peter Molnar already demonstrated, also you can perform individual factor analysis. You see for this individual you have a different factor structure than for this individual, and if you look for a sample of individuals, all the factor structures seem different. Here you see the variability of one individual, the variability of mood, and the interesting thing is that it's an important information about the process. If you look at this individual, you see in the first phase there is high variability, and the second phase the variability is lower. The reason is there was a therapy starting in the middle period. But the important thing is the measure of intra-individual variability gives you an important information you normally would not have. In cross-sectional study, you can't have a measure of variability, which is interesting for itself. So that's the same as Peter Molnar said with other examples. Here you have 4 individual processes, and which are quite easy, and the characteristic, there are learning curves. Student 1 learned something at this point in time, and then he has learned. For student 2, the same behavior he learns at another point of time, and student 3 forgets at this point in time, and student 4 forgets at this point in time. There are simple learning curves with just 2 states, learned or not learned, and each individual has just one change from not learning to learning, or the other way around. What happens if we look at the sample is the sample curve is here. You see that the sample process has more than one changes, and you see there is a growing and a declining, and none of these individuals has growing and declining. Only one of these processes either growing or declining, but in the sample process you have a complete different process. And if you want to transfer from the aggregate process to individual shapes, you would be wrong. That are real data from smoking behavior. What you see is individual time series. There are on this axis there are days, and on this axis the amount of smoked cigarettes. And the idea was to reduce the amount of smoking. And each picture has 2 informations. One about the individual. For example, here, that's the smoking behavior of this individual. And also contained is the sample curve, sampled for about 200 individuals. And what you see is that what Peter Molnar said already, if you look at the aggregate curve, you would say the amount of smoking decrease continuously a little bit. But what happened, the individuals, for example, this individual, there's a high amount of variation. Then at one point in time, he stops, and he stops smoking and never smokes again. If you look at other people, for example, this, there is a decrease in the amount of smoking. There's a time he doesn't smoke, but then he's a drawback and he smokes again the same amount as before. Here you have the interesting phenomena. You have an increasing amount of variability, but then there is again one point in time, and then he stops smoking. Here you have no change in smoking behavior, only a rhythm, which may be due to weekly changes, and so on. If you look at this individual trajectories, you see they are totally different, and if you try to infer from the sample curve to the individual, you will have no valid information. And what could you do? The idea is to look first at the individual time series and then try to understand and then to combine individuals with similar processes. And you have, as a result, not only individual curves, but you have groups of individuals which show the same behavior. That's what Molnar's algorithm would have as a result. Okay, that's another important point that's really important about the temporal distance in studies. Here you see behavior of an individual which has a clear structure, and we would say it's a rhythm. How can we detect this rhythm? If we use 2 points in time, as we normally do in longitudinal studies, we would not be able to detect this kind of rhythm. If we would take 4 points in time, these 4 points in time, we wouldn't be able to detect the rhythm. We need enough points in time, as here, to detect the rhythm. So if we are interested in process, we need enough measurement points, that's one thing, but the distance between measurement points is also important. And sometimes we will not detect process parameters which are important if the distance between measurement points is too long. And normally in longitudinal studies, if we look at years or half years, we will not detect the process which are important. So that's a really problem in normal studies. Aggregating, you have seen this picture already 2 times, it's the 3rd time. So I can make it short. Cattell's data cube, inter-individual and intra-individual analysis. Here you see a synchronous relationship between 2 variables at the same point in time. And here you see asynchronous relationship if the red line just before the green line has its high values and also the low values. That's an asynchronous relationship. And that's the example which says, again, the same thing. I want to explain the example. It's an artificial data set dealing with the inter-individual and intra-individual relationships. We have 2 variables, control belief and performance. And we measured these 2 variables for 4 individuals, 1, 2, 3, 4. And if we look at time point 1 and we correlate, we build the inter-individual correlation, it turns out to be 0. That's the inter-individual correlation at one point in time. What we are interested in are individual relationships, and therefore we ask what happens with the individual. That's the blue. If we look at individual 1, and we have the same variables and we correlate, we build the intra-individual correlation for this individual is -1. So the inter-individual correlation, which we normally compute in cross-sectional studies, will tell you nothing about the individual relationships. And you could argue, or maybe it depends on the point in time. You see the inter-individual correlations are the same for each time point. They are 0. And you could argue the individual relationships are different. They are not different. They are the same. For each individual, the intra-individual correlation is -1. So you can nothing transfer from sample correlation to an individual correlation. Now you could argue and say maybe that's because of errors of individual data, and you aggregate across time. We have 4 time points, and that's the mean of the 4 time points. This column is the mean across these 4 time points, and if you correlate these mean values, you get a correlation of +1, which is also different for the inter-individual correlation as well as for the intra-individual correlation. It doesn't help you. The message is the same: don't conclude from sample data to individuals. That's a formula which relates this kind of correlations, the intra-individual correlations and the intra-individual correlations. And the parameter which is important is this eta square, which is the amount of variability, the relative amount of variability. And the message is you could relate this kind of correlations. Here you have empirical data which demonstrate the difference. Here we have from this TV viewing behavior, we have diet, mother and adolescent. It's the viewing time for information programs. And you see the mother views more than the adolescent, and if you look at the intra-diet correlation is 0. If you look at another diet, intra-diet correlation is 0.53. And this is the distribution of the intra-diet correlations, and you see they vary from minus values to very high correlations. The intra-individual relationships can be different, and if you compare the inter-individual correlation with the intra-dyadic correlation, they are also different. Here you see well-known example from biology, the dynamic interaction of 2 populations, and you see in this rectangle one that we have 2 populations, and the amount of animals for this population varies, and you could not understand the change in the amount of population over time until you analyze the relationship between these 2 populations, and one is the predator and one is the prey. And what you see is here, if you look, if the number here is high, this population is also increasing, then this population decreases, and lagged also this population decreases. It's a lagged relationship between this kind of populations, and that's what are cross-legged relationships, cross-legged correlations. The important thing is that we have normally cross-legged panel analysis. We do it for samples, and the argument again holds: you cannot conclude from sample results to individual results, also for this cross-legged correlation. That's the same example we had before. Now we have two variables, control, belief, and effort, and I also added the lagged variable, and we have the same relationships. If we have the cross-legged correlation for the sample, which is 0, and the cross-legged correlation for each individual is -1. It's the same example, slightly transferred, but the same message. You cannot, from this cross correlation, conclude to an individual cross correlation. Okay. 2 arguments. You should look to processes. Second argument, you shouldn't aggregate. Now, another kind of analyzing processes, intervention analysis. We have the opening of the German wall, and the time series is again TV viewing behavior for information programs. And we tested the question whether the opening of the German wall had an effect on the interest of adolescents for viewing information programs. And you see slightly after this event, the amount of viewing is higher than normally, and you could test it with special time series methods, intervention analysis or transfer function analysis. The idea, I show it, the advantage, normally if you do intervention analysis, you could say the intervention has an effect or the intervention has no effect. Using time series, you could look for the kind of effect. For example, here you have an event and only a direct effect when the event happens. And here you have an after effect, and the reaction is, in this case, is decreasing, and the decreasing here takes a longer time. So you can analyze the kind of how an intervention works, and they are totally different time shapes. For example, here you have, after an intervention at this point in time, the reaction comes to a new level, but with a different amount of variability. Here you have a low amount of variability, and here the system shows a very high amount of variability. And you could test this reaction to events. We have 2 kinds of events. One event is only for one point in time, or we have enduring interventions. So we have different kind of reactions. Now I want to tell that are studies which we plan, where we want to do interventions to have an influence on process parameters other than just means or mean levels. Here you see it deals with self-regulation, and here you have students which has a high amount of self-regulation and a high amount of variability of self-regulation. For this individual, we have a high amount, a high level of self-regulation, and a low variability of self-regulation. We assume that a low level of variability is sometimes better than a high level of variability. I want to explain later. But the information is we look at 2 process parameters for each individual, the level and the variability, and in addition, we look also at the relationship between the variables and try in interventions, in trainings, to change the individual relationships. What you see here is, in the upper part, there are three variables: goals, effort, and time use for each day for one individual. And you see the trajectories for these three variables are very different. And our idea for the intervention is to couple, to synchronize these variables with respect to the goals. If you have high goals, if you have difficult goals, you should invest more effort and you should invest more time. That means we want to synchronize these variables and we do an intervention first in the baseline phase. We measure these variables and then starts the intervention, and we assume that the individual relationships between these variables changes because of this intervention. And also we could then use dynamic factor analysis, and we suppose we have a different factor structure after the intervention. The factor structure here has more factors because the variables vary individually, or each variable has a different time trajectory, whereas when we have a synchronization of all the variables with respect to goals, we have only one or only a few factors. So we want to change the individual factor structure by training. We also want to change the leg structure for each individual. I explained in the self-regulation model that we assume a relationship between today's learning and tomorrow's learning, and how we want to intervene. We ask the students at the end of each day what goals you have for tomorrow, what want you to change tomorrow. We ask at the end of one day, and we ask them again at the beginning of the next day, and therefore we hope to have a relationship between yesterday's learning results and today's learning. That's an asynchronous relationship, and we want to change this relationship by the idea that it would be good if you have ideas at the end of one day and you apply it the next day. Therefore, we want to change the dynamic structure. Here you could say it's artificial data, but here you see you have three variables which have not much relationship, and here these variables were more synchronous after this intervention. We also want, by an intervention, to change the rhythm. So sometimes it's good for learning if you have habits. If you do it all at the same time each day, you study your self-regulated learning. And if the case, you have a more clear rhythm. So we want to do an intervention which changes a process aspect, the rhythm of the learning behavior. Okay, I wanted to give you examples of processes, a lot of different processes, and I want to show the advantages of process analysis. I showed you the problems of aggregation for univariate process, for bivariate process. We looked for multivariate dynamic relationships, for synchronous and asynchronous relationships, and I pointed to the advantages of intervention analysis, because you can test not only has an intervention an effect, but how is the kind of effect. Is it directly or it takes some time? And I gave you some ideas for our future studies where we plan interventions to change the individual structure, not only for the mean, which is normally done, but also we change the variability and the internal structure. Thank you very much.